Hey, welcome back everyone. This is going to be lecture number 3, ROS messages, services, and actions. It'll be a great lecture, although a little bit longer as we study these 3 really core components about the ROS framework. So we'll be looking at 3 main ideas. Number 1, how to generalize publishing and subscribing through custom messages. Last time we looked at a lot of standard messages, but this time we'll look at custom messages which are going to be used when you have any specific implementation for an algorithm or for a specific robot that you're using. Then we're going to look at raw services that guarantee receipt of messages, but they are a blocking type of communication. They're going to be very useful for you, and you'll use it a lot. Finally, we'll look at ROS actions that also provide guaranteed receipt of messages, but different from services. They're non-blocking and usually work for long-term tasks, as we will see. Okay, let's start with ROS messages. Did you know that ROS has 14 built-in message types? If you don't remember from last time, we can open a terminal and just use the command ROS message show, and we could type any number of alternatives. In my computer, I have both standard and custom messages, so you can see a long list. In these message types, we have what is called fixed length. When we create vectors or arrays, we can set the size of these arrays. But we also have some that are variable length that might be useful when you are unaware of the size of data that you might be using. And as you get more familiar with ROS and different packages, even through GitHub, you'll see that many people have already created many custom messages that you might use in the future. So here's a list, just as I showed on the terminal, of different message types. Complex messages can be created either by individually listing all the elements of a message or by compounding pre-existing types. We'll see some examples of that very soon. Standard messages. For ROS, some of the standard messages are listed here. We have booleans for true and false. We have chars if you just want to enter letters, or colors, duration, which is a time variable. We have floats, float 32, float 64, and we have single or multiple array variables. We have integers, we have strings, and we have unsigned integers as well. So here under standard messages, we have 32 types, and most of them, though, are single element data. One interesting type here is the standard messages header type, or header.message. You will see that the header message type is included in many other message types. The header message is composed of 3 elements. The sequence, which is just a basic counter. Every time you publish a message, this sequence can be programmed to increase by size 1. This can be useful to compute, for example, how much time has passed from the original message that you published. We also have a timestamp. The word stamp here means what is the time at which this message is being published. I might say that the timestamp is not exactly accurate from the time that we publish, because it is first recorded in code, and a few milliseconds or microseconds later, it is actually published. And then there's a frame ID element. If you care about which frame of the robot this message is associated with, then you can type the string version of that frame here. To learn further about custom messages, we will be working with a package called example ROS message. If everything is working with your system, you can easily find it by using ROS-CD, example ROS message. You'll notice that this is located in Learning ROS Part 1, and right there you can find example ROS message. Now, if you're working with a package for the first time and you need to create a custom message, the first thing that we need to do is create a folder called message. So let's go back here to our package and list all the existing elements in our folder. And here you'll see that we have a folder called message. It is here where you want to include any of the definitions for new custom messages. Then we need to create a file with the following standard: name plus .message. So in this case, we'll create a custom message titled example message.msg. You can find it right here. If you wanted to create extra example messages, you could provide a name right here and append the .msg extension. Okay, then within the file we need to include a line which specifies the type and then the name of that type. And this is what will be used in either C++ code or Python code later when we want to enter message values. So let's take a look. Let's use the less command on the terminal to quickly see this message. Okay? So any pound sign like this means comments. It says we can enter any primitives like int 8, 16, 32, 64, or floats or strings, time or duration, or anything like this. So for example, right here we have a complex type. This is the standard messages header can just be written in this way, and then we'll give this message the name little header. Secondly, we have int32. We'll name that demo int. And thirdly, we have float64 type, and we'll call that demo double. So this demo int and this demo double, along with the header, are going to be data elements that we will be filling out in our C++ code later. Okay. Now, if you want to exit this window for less, just press Q, and you'll return to the previous window. Okay, the next thing that we want to do in order to define our custom messages is to modify our package.xml dependencies. So we would go back to this file and normally include a message generation and message runtime dependency here for ROS system to be able to build the appropriate header files which define our message types at the time of compilation when we run catkin make. Okay? So in this case, we could open here, package.xml, and go to the bottom of this package. And here, for example, we could see message generation and message runtime. Okay? Let's move on. The next modification that we need to make is for cmakeLists.txt. Now, for a regular cmakeLists that is not using catkin simple, 3 modifications would be needed. As you can see, I've provided you a link to the tutorial on how to define custom messages. This would normally require changing or appending the package message generation flag, the catkin depends message runtime, and then the specific message files. But if we're using catkin simple, none of this needs to be changed and all of this will be taken care of. For example, if we open CMake lists, you'll see that for the Catkin simple version of this file, everything is very, very easy. Later on, we will, work with this executable, or actually work with these 3 executables. But other than that, we don't need to enter any details related to message generation. So here, Catkin simple really simplifies our life. Although sometimes the downside is that it might be compiling things that we don't want and make our package machine code a little bit larger. So once you know more about that, you'll be free to choose what kind of Catkin environment you want to use to compile your code. All right, so there it is for reference. So we have our custom message, and we run catkin make from the top of our package, right? We can go there with raw cd, and we would run catkin make. And if you just want to make that custom message, we could do that by typing the name of the package, example, ROS message. Okay, so what happens at this time? Well, the key thing to know is that a header file that actually defines that message is going to be created under the folder ROS workspace, development, include, followed by the package name and then the name of the file. Let's go take a look. Change to the development. Okay. Here we have lib and include. Let's go to include. We'll have a lot of package names. And here we have example ROS message. And here we have example message.h. Let's take a look at that one real quick. You'll see that's a little bit more complicated file, but you'll see that here you have your demo, you have your header element, your demo int, and your demo double elements that we included in our custom message.msg file earlier. Okay, so anytime that a node wants to use this custom message, we'll need to include example message.h. Okay, and the package, for any package whose nodes want to use this custom message, we need to include the name of that package in our dependency list. The C++ code needs to include the header, and normally what we're going to do in the C++ code body is, number one, create the object for the message type. So the way that we define the message name, that will become the type, the C++ type. We'll need to declare it and create an object for it. Eventually, we'll fill the appropriate data and finally publish it. So let's look at this CPP file to get an idea of how this can be done. Okay? And the basic structure of the C++ file is going to be declare the ROS headers for ROS and your custom message. Then we need to create a general publishing object that's going to publish our message data. Then thirdly, we're going to create that custom message that we're going to be filling in, and finally publishing it out. Okay? Let's move over to example ROS message publisher.cpp. So here we can use ROS set and then put the package name, example ROS message. We can double tap to see every file that we can open here, and here is the one that we're interested in right now. So we can type example ROS message publisher.cpp. Let's maximize the screen and take a look. We always start by including ross.h to get access to all the ROS CPP API functions like init, node handle, publisher, and the like. Secondly, we need to include the header file for our custom message. The way we do that is we we type the package name followed by the name of the custom message.h. If everything has been compiled successfully and your terminal is sourcing your workspace, it should be able to find this. And then if you need any third-party libraries, you can include them here. Okay, so we'll initialize this node with the name example ROS message publisher. We create a node handle n, and then a publisher object called myPublisherObject. Now here, when we advertise this message to the ROS master, we can tell it what type this topic will be. And slightly different from the inclusion of the header, here we can use the scope operator to take the class and then, or the namespace here, and then the class of message. So example ROS message, example message. Here we're gonna select the topic to which we want to publish and set a Q element to 1. All right. So here we advertise this topic, we have a name, and we have a type. The next thing we want to do then is create the object for our custom message. As before, here is our type, and here is the instantiated object, which we will call my new message. So according to our custom definition, there's going to be 3 elements for this one: header, demo int, and demo double. We can see that immediately in this chunk of code where we take our object my new message, and notice that now, because this was instantiated simply as an object of the class, we can use the dot operator to access the header. Now remember, the header has 3 elements in turn: the stamp, the sequence, and the frame ID. So you need to be familiar with each of these elements in order to provide them with the right values. Stamp can take a value coming from the ROS time class and then accessing the now method to return the current time. So whenever the code is running and it reaches this line, that's the time that it's going to be assigning to this element. Here, the very first time we want to provide a value to the sequence, we can say 0, and the frame ID can be a string. In this case, we're going to call it a base frame. Here we currently have no robot, so this is just a very simple example. Such frame names would come from the URDF file, which we'll introduce on week 4. Finally, we have an int, so we provide a value like that, and a double. Okay, so this is probably you often want to do this to initialize your message, and probably later you're going to update it based on some particular conditions that are interesting to you. For ourselves, we're going to have a while loop, and basically we're going to increment this data using some simple logic. Remember that anytime we're going to be working with while loops in ROS, you're going to want to control the timer for that while loop. So this was done earlier in the code through the rate class, where we set the frequency to 1 hertz. And so again, here we take all those elements in our custom message and we modify them with each iteration of the loop. The sequence is just incremented. The stamp gets a new, the timestamp gets a new stamp with every loop. The integer is multiplied by 2 with its current value. And then for the double, we're computing the square root. After we update all this information, we can just publish it by calling the publish method on the publisher object and then passing that message. Fantastic. So hopefully that gives you an idea of how to fill out and publish custom messages. Okay, once you have this code here, you would then add it to your cmakeLists.txt and cat can make in order to have this executable ready to go. With catkin simple, we can do cs add executable and then provide a name for this node, example Ross message publisher, and then provide the path to the CPP. For messages that have variable length, like vectors, we're going to introduce some code coming up soon. And vectors are used very frequently. Normally, you're going to be pushing back data that is of interest to you, where things will be growing. So here is a table that helps us to relate ROS types with C++ types and Python types. So fixed length arrays are similar to boost arrays or just simple standard vectors. If you're familiar with the standard vector in C++, you know that you can access methods from the class like pushback or pop. These are going to be, all these methods will be available for the fixed length type in ROS. The equivalent of that in Python will be a tuple. Variable length, where the size of the vector can grow in ROS, is equivalent to the standard vector in C++ and also to the tuple in Python. And then for uint8 and bool8, you have these equivalents for your reference. Okay? Now, in our custom messages packages, we will have some examples for variable length and fixed length. Let's take a look real quick. Okay, this is also located in part 1. Okay, and here we have some message types. And here we're going to introduce the vector of doubles, and we'll describe that in a second. Okay, so inside our vector of doubles, we have this type float64 without a fixed length here. So it's of variable length, and we call that double vector. Let's take a look. There it is. And we can also show that with custom messages vector of doubles here. Okay, so this is another custom message that we have created that is going to be of variable length. That is to say, it's a vector that is going to be able to grow in size by pushing new data into it. We will also be freely to resize it if we so choose. If we edit this and include the dependencies and package XML, and then run catkin make, we will be able to find the header file definition in this location. You can look at that yourself for reference. Okay, so we have some C++ code here that will be using this custom definition. It's called vectorpublisher.cpp, and it's going to be part of our example ROS message class. And in this code, just as before, we'll have our headers, publisher object, then we'll create the vector message object, we'll do some handling of the C++ vectors, and finally publish the custom message. Let's open that file. Sorry, it's example ROS messages. And here we can open vector publisher, sorry. Okay, ROS header file, and then custom messages vector of doubles.h. We initialize the node, node handle publisher object with our new custom message. And here we declare the instance of our variable length vector. We'll call that vector messages. We'll use a counter, set that equal to 0. And so here's our object vector message. And we can access the element double vec. This is the actual array of the object. And just as in a standard vector in C++ or a tuple in Python, we can call the resize method and set it to any size that we want. And after setting the size, we can choose a particular element and assign it a value, just like we would do with the standard C++ vector. And alternatively, we can use methods for the vector class, such as pushback. So here, for example, we can push back the value of a counter that was initialized at 0 here, but that we're going to increment in a while loop down here. So we can take that vector message, double vector element, and push back an increasing counter number and publish that with each iteration of the loop. Now notice this can be dangerous because that number will continue growing over time. Right now, the frequency of the loop will just be 1 hertz, so it's reasonable. But if this was growing at 1,000 hertz, that might be a problem for you. So let's then run this code and take a look at how this might look like. Yeah, and I point out to this on this slide over here. Remember to compile, and for any package in which you want to use this custom message, include the dependency in the package XML, just like this, and modify the cmakeLists.txt such that you have your node that you want to run. This is going to be vector publisher. Okay, now let's run the node. For this case, we'll need to make sure we have ROS core running first. Whenever we don't use launch files, we'll need to start ROS core ourselves. So here we say ROS run, example ROS messages, ROS message, and this is going to be the vector publisher. Okay, so now it's running, but now what? We can't see anything. So the next thing we want to do is echo the topic from our node. Let's open a new terminal. You can do that quickly with Control-Shift-O. Just notice what nodes are running. Vector publisher. Let's see what topics are running. Vec topic. So here we can say ROS topic echo, vector topic. And notice that with each second, this array is growing by size 1, 40, 41, 42, 43, 44. And so the size of our vector will continue to increase with each iteration of the loop. Okay? This is what is referred to as a variable length type in ROS. Okay? Let's kill this and the node. Now, if you want to handle this data through a subscriber, we have an example of that here in vector subscriber.cpp. Okay, and here what we want to do is in the callback be able to handle an object like this. Let's go ahead and take a look at that over here. Let's close this window, maximize this one, say ROS set, example ROS messages, vector subscriber.cpp. So here we have what seems a very simple piece of C++ code. Here's our headers for ROS and for custom messages vector of doubles. Then let's look at the main function first. Sorry. We initialize our subscriber, vector subscriber node. We have our handle. We have our subscriber object, to which we provide a topic, a queue size, and a callback called myCallback. After that, we immediately call spin. Remember, this is a blocking function, and it indicates that as soon as we have a vector topic, a message published on the vector topic, the callback will be called automatically. So here we always include a constant term because we do not want to modify the value that is incoming. We just want to read it. And we pass this value in by reference to avoid an extra copy. And this is a variable name that can be changed freely. In this case, it's called message holder. So here, we're going to simply read what is being published. So we take this element vector of doubles and initialize it with a C++ standard vector and assign it a double type. And how do we pass that value in? We have message holder and then double vec. Okay, this is coming from our custom message definition. And after that, we can read the size using the size method for the standard C++ vector on here, vector of doubles, and then take that and use a for loop to print out the information in that vector using ROS info. This is using printf notation. So here we will look at the index of that array and then set it equal to the actual value of our vector. And then skip a line for each entry. Okay. So remember, once you have this code, we want to then compile it. Now, an easy common programming error is that we don't limit the size of our vector, so it can consume all of our memory. Be careful also that you do not access memory locations that have not been allocated. For example, if you say, let me access element 4, when you only have a 3-element vector, you'll get a runtime error. Remember that vectors or arrays here are indexed starting from 0. Let's take a look then at how this might run together. All right, let's open that. We can say ROS run, example ROS message, vector publisher. And before I type enter, let me start the subscriber first to show you that you can also do that. In this way, nothing is happening, but as soon as we hit enter on the publisher, we see a subscriber that increasingly outputs data from the growing array. Okay, fantastic. So this finishes our module on custom ROS messages, and we will now continue with ROS services.